Good afternoon, and thank you, Ian, for the very kind introduction, and also safeguarding me by saying that I just arrived last year, so I could not possibly have done so much to the project yet. So then that's a good starting point. Thank you very much, and good afternoon. So this is the session 2 about the look into the future. So I talk about the predictions of the grass grow into the to the end of this century. But before I start my talk, I'd like to start by congratulating on this 25th anniversary. As I said, I just joined last year, so I have no bragging right. I haven't achieved anything. But all the people who have been involved in the project over the last 25 years, as someone said in the slide of this morning, this was very much ahead of the time when it was launched, and it is my honor and pleasure to be part of that now. Back in 2005, when the seminal paper by Sinclair Scott and Peter was published, I remember myself reading every sentence, every equation, just like a Bible. And so to be part of that journey from here onwards is really, really exciting. Also, the involvement of the agri-research to expand the project to the farm network. I was back at the, Rosam said, I was part of the GrassCheck GB project. I had got numerous opportunities to talk to GB levy boards of AHDB, HDC, and QMS. And I cannot count the number of times when their levy board people said to me, oh, I'd like to pick on Jason's brain on that. So Jason has got this slightly cult figure, really very much revered by the GB levy board for the success of running the farm network, and there's so much to learn from that. So as a long-time outsider looking in, I'd like to just say what a great achievement this has been, and again, many, many congratulations. So before, I will start talking about the grass in Northern Ireland in a minute. But before doing that, I'd like to emphasize how important it is to have long-term trials like this, long-term research projects. The vast majority of research projects around the world finish in either single year, 2 years, or 3 years. And there are so many things you cannot know from them. So I was at Rosam said before I joined AFBI in England, and then this is one example of the long-term trial. And I'll just show what we could have done, and we could not have done without these data. So the Broadbog trial, as you may have seen, started in 1843. And since then, this is recognized as the oldest running trial, any scientific trial, not the agricultural trial in the world by the Guinness Book. And so it has maintained exactly the same the experimental design for the last 180 years. And so in Victorian time, our technicians were collecting data as such. And these are all still stored so that we could analyze these data. And what we did, just before I left there, this is one of my last projects there, and what we did there was to analyze the fate of the nitrogen, what would have happened to the nitrogen since 1843, looking at the different treatments of the no fertilization, on the organic fertilization, manure fertilization with livestock manure, and the combination of both. And by fate, I mean that the nitrogen has to end up somewhere. It could be either uptaken by plants or stay in the soil for the future potential use, or it could be gone forever to the environment, either to the atmosphere or to the watercourses. And we split them between these. And what we found, this was a staggering result, that as you intensify inorganic system more and more by putting more fertilizers in, the proportion of the nitrogen that would be lost forever to the environment exponentially increases. So that means that, yes, on a per hectare basis, to get high yield, you need to fertilize. But if you do too much, then proportionally, you are losing more money because the higher proportion of nitrogen ends up not being used at all. And what we found here on top of this was that if you fertilize with organic nitrogen in the form of livestock manure, then you are able to stop this trend even at the reasonably high level of the fertilization. This was 240. And then therefore, this combination of the inorganic and organic and the fertilization regime is absolutely critical for both arable agriculture, but also silage production as well. In addition, we found, contrary to common belief, that when you measure the nitrous oxide emissions from the soil, then those soils fertilized with organic nitrogen in the form of livestock manure had got significantly, dramatically lower level of the emission rate on a per hectare basis. So what it means to the livestock industry is that if you just say that, okay, livestock is not good for society, therefore we have to reduce the numbers. Yes, there is some element of that, but if you blindly agree on that, then you have got no manure to fertilize even arable land, and therefore how can we maintain the soil fertility? So it challenges the conventional wisdom that no livestock is a better agriculture. So all these things, my point is that we wouldn't have known if there was no long-term data and long-term experiment. It is not glamorous because year in, year out, week in, week out, what we do, what our technicians do are very, very mundane. But these are the foundation of the discoveries. And so I would like to thank AgResearch as well as the DERA for supporting our program to date. Now, coming back to the, not coming back because I haven't even started talking about Northern Ireland, but now the key question about the grass growth here. So what is important when we look at the data from the past 25 years is to split the impacts of climate change from mere impact of the year-on-year weather variation. So to form hypothesis, what we first did was to look into the first 20 years of data. What you're looking at here on the screen is the weekly growth rate. Each dot corresponds to each year in different color. And then, as you can see, it starts from the March and then to the November. And then you have got the typical conventional growth curve across the 20 years. When you split that into the first 10 years and the second 10 years in the hope that we can detect some trend, this is the first 10 years from 2001 to 2010, first 10 years of the GrassCheck project, and this is the second 10 years of the GrassCheck project. When you place them side by side, and just by looking at, without any statistical testing, it may be difficult for you to immediately detect some of the patterns. But what we confirmed was that for the latter part, there is a tendency that you have got the better early season growth, and the B, and you have got the later peak on the whole in the summer, and C, and you have got the greater variability between the years, between 10 years of the second half. So these are the starting point of our analysis, and then we wanted to look ahead for the future so that we can back calculate and back inform what kind of farming strategies would be required and preparing for the future. So to do that, because we don't have the future, we need a computer model. And we, as I said, I inherited a very expensive and very high quality toy from my predecessors. And so we can use that for this purpose as well. And what you are looking at is a comparison last year of the predicted value of the grass growth and the observed value of grass growth. And there was a drought in around June time last year. And when we publish the prediction value, we try to be conservative, meaning that we don't want to over-predict, because then there is a risk that you may put more animals onto the paddock and that they don't have enough feed. So if anything, we tend to be conservative, and we underestimated slightly during that drought time. I apologize for that if you bought some feed in at the time. But overall, our model has got the error of about 12 kg per day at maximum. And so when you compare these values against our competitor models around the world, especially the temperate grassland in Europe, then it is as good as, if not better, than the vast majority of them. It's not a competition. That is not the important point. But what is important here is that if you only have got the error of, say, 10 kilograms, then chances are reasonably low that this misquotation of the value will lead to grossly wrong on-farm decisions on your farm. So that is the important point. And therefore, we have got the confidence to talk about the future using this model, but using the future climate prediction. So to do that, we sourced the climate prediction data from the Met Office, and then applied the same model for the whole of Northern Ireland. And this is the tendency we observe. So UK Met Office climate projection starts from 1900, when we were not measuring the weather data accurately. So this is also the prediction backwards. So between the 1900 to 2100, and this is what we believe the grass prediction would typically be in Northern Ireland. There are many dots here because there are a level of uncertainty about the future and also the past, and therefore you cannot just draw a single line. It could be somewhere between the two orange lines, and it is most likely to be around the green line. So between now and 2024 and 2100, our estimate is that the grass growth will be greater by approximately 2 tons. And this is great news. So of course, there is the implication of the farming on climate change, and we have to collectively address that. But when we just take the climate change as given, there is some positive news that we will have more resources to play with. And now the challenge is, okay, we know that, but then how do we want to play the game? And when you look into the data in greater detail, this is the month-by-month prediction starting from March to the November. What you can observe here is that from March to, say, April, but also early May, we predict a very monotonous, basically a consistent increase in the grass growth. And that's also the case for the October and November. And in a nutshell, the reason why we think we observe that is because for those months, the current limiting factor of the growth is temperature more than anything else. And as a result of the future climate change, we are basically removing the limiting factor to a great degree. On the other hand, when you look at the value in June, July, August, the height of the prediction, the growth season right now, and we don't have the same tendency. In many years, the prediction is actually down as the future unfolds, and more importantly, the pattern becomes wider in vertical direction, meaning that it becomes less predictable, more volatile. And this is a big issue in terms of the farm management, as I don't have to tell you, I'm sure. When you split that further into the 10-day period, then you can confirm what I just described in a slightly greater detail. When you compare the first 100 years and the second 100 years, what you are seeing basically is that For the early part of the spring and late part of autumn, you almost always have got as good or better prediction. Whereas in the summer, there are some years when the prediction is astronomically high, but in many, many other years, it is down. And combined together, it is very volatile. Now, okay, it's all good to know that the future weather and therefore future grass production will be volatile, but that cannot be used on farm. So what does the volatility actually means? And we are now running a program looking into this issue, but this is just one example of what volatility may look like. And I conclude to pass it on to what we can do in the future and to be discussed by my colleague Debbie Patterson. So in the GrassCheck plot trial, to mimic the vast majority of the grazing situation, we split the fertilization of the 270 kilogram of nitrogen 10 ways. So the amount slightly varies as the time goes on, but simply put, it's about 27 kg of nitrogen per application. Suppose that we are interested in the value of a single fertilization event here, let's say number 5 here. We want to know, okay, what was the value of me buying fertilizer and putting that into the field? One way to quantify that is to compare the situation where you apply the fertilizer all 10 times versus the situation where you apply the fertilizer only 9 times, all times but the 5th time. And when you compare the yield from the first situation and the second situation, then that would be the value of the incremental value of the 5th fertilization event. So what we did was to repeat this process for all 10 of them for all 200 years. And what volatility means in one form is as follows. What you're looking at is the probability of what we call nil returns, whereby you apply, say, 27 kilograms of nitrogen as part of the 10-way split of the fertilization regime, but you didn't get more than a certain level of the grass in return for that. So I set the threshold at 100 kg, 200 kg, and 300 kg as a return to 27 kilograms of nitrogen. This year, there was no case whatsoever, regardless of the climate prediction, whereby the return was less than 100 kg. If you apply 27 kilos, then you always get at least 100 kg. And there was only 5% chance that you get less than 200 kg. So in other words, the return to the investment is not exactly guaranteed. They fluctuate, but it's quite certain. In 2100, using exactly the same model, and there are cases where you don't even get 100 kilogram of incremental yield from this fertilization event. And when it comes to the threshold of 200 kilograms of dry matter, the chance of that happening is more than 3 times greater compared to the what we are experiencing right now. So that means that when we think about future farming direction and also future farming research direction, one key to climate adaptation is to manage this risk of nil return. How can we make it not happen? How can we prevent for our investment to not to be from not being returned at all? And what David and Brendan will talk about will include all these different strategies. For example, you can change the soil structure to and have better return all the time. Or you can stop using nitrogen and rely on alternative method so that this risk doesn't exist to begin with. So once again, all this modeling and the long-term data, thanks to the long-term funding and vision, is helping us think about all the future farming strategies and also, therefore, what we can do today to inform you better. I enormously enjoy reading your questions and comments on the Slido as well, and the questions on the field, so that we can think better about what kind of priority we should place in our research program and into the next 5 years and maybe 25 years as well. This is the end of my scientific component of the talk, but just before I finish, as a housekeeping, I'd like to just talk about a few things that are to happen next year, and we are developing all these initiatives right now. So one is that just the slide of poll was showing that you'd like more the advice on fertilization. Just as I explained what would be the value of the next fertilization, we are working on the model component to give you better advice on what you should do, to fertilize, not to fertilize, when to fertilize. The second thing is improve the prediction under the drought, where we haven't had many droughts so far, and compared to in the future, and therefore this is probably the weakest part of our prediction model compared to our global competitors. And we are working to work on this in the expectation that even at this part of the world we'll have more drought. And thirdly, I was going to say that we are also working to make it happen so that we can predict the growth on 7-day and 14 basis for all 6 counties separately for Farming Life and Irish Farmer Journal. But I was looking at the slide poll, and then this was the least popular option of all of them. So I'm a bit sulking about it. So it may not happen in the near term and in the near future. Finally, this is a serious comment, as a foreigner and an expat working in a local environment, I realized that to deliver the current portfolio of the project to fill the local skill gap is only half my job. The other half of my job is to ensure that when my piggy bank is big enough so that I can happily retire, there is a constant stream of local talent and the locally based talents who can replace me and then move the Northern Irish agriculture into the future. So in that regard, I'm very grateful that the AgResearch is funding a 2 PhD project. And I think Peter is here today, somewhere there. Yeah, and Peter McCullin there included, and working on the extension of the GrassCheck project so that we can provide more useful information to the Northern Irish farming community. Thank you so much for your attention, and please, so I just provided all the problems that we have got right now, and it's now time for David to give you all the solutions. Thank you.